Today let's start tutorial 17, sequences and series. Now this chapter, right, is the sigma chapter lah. Okay, and then the thing is that we will rely a lot on AP and GP, but because we're doing summations, that's why we're relying a lot of AP and GP, the formulas that we used to know. But the problem is that you need to be very familiar with the number pattern general terms. Okay, and at the same time, you need to be very familiar, you need to be very mindful of the detail. When is it +1? When is it not +1? Okay, when is it from n to 2n, that kind of thing. Okay, you need to be very careful. When do you start with 0? When do you start with 1? So these kind of small details are the trap in this chapter. Okay, now let's also, because in view that a lot of people are not here, I just go through the whole chapter myself. Don't have to worry. I'll just slot you in differential equation because that one I let you explain differential equation. Okay, can all right. So okay, so for question 1, this question is an exercise to let you familiarize on what does the notation mean, sigma notation. Okay, so what does this mean is we are summing from 1 to 5, 1 over r factorial. Okay, so meaning what changes, what's the variable in this question? The variable is r. Okay, so even though if you see n, that will be not the variable is r. R equals to 1 until 5, then you sum 1 over r factorial. So it's just like that. Okay, so technically it's an exercise for you to slot in where the r. I think some of you went the extra step of evaluating the denominator and summing everything up, which is okay, but not part of the question, because the question is just expressed as the sum of its term. That's all. Okay, technically it's just an exercise to get you ready lah. In all honesty, there's no, like, usually we won't ask this kind of thing because too easy. Can use GC to do one. Okay, now let's look at, okay, part B. We have sum from r equals to 0 to 5. So this one a bit different from 0. Then we have this component over here, 2 to the power r plus 1. Okay, so this one over here is okay, we just need to put in 0 lor. Okay, when r equals to 0, we have power 0, power 1. When r equals to 1, power 1, power 2, and all the way until power 5, power 6. Okay, now the thing is that this component, you need to be very familiar with it now, because sometimes when we have a sequence with alternating positive and negative signs, then we will need to include this sequence. Okay, remember I told you about this? Sometimes it's power r, sometimes it's r plus 1, r minus 1. Okay, this one you be careful. All right, so yeah, something like that. Very easy one. Okay, then for part C, you have this. So it's just sum from n to 2n. So the variable is r, but you are getting from the number n until 2n. Okay, so it's simply just adding this, subbing in n plus 1, n plus 2, n plus 3, all the way until 2n. Okay, now technically speaking, right, this one is just for you to get used to it right now. But I want to say something a little bit off syllabus. Okay, I want to say something a little bit off syllabus. The thing that's slightly off syllabus, right, is this one. If it's still around, it will be guided for you lah. Okay, if it's still around, it will be guided for you. Okay, so there's this technique called the method of difference when we want to add what do you call when we want to add things. Okay, so what we need to do is we need to break this out to the partial fraction first. Okay, so 1 over r plus 2, right? This one can be a over r plus b over r plus 2. So a would be equals to correct. So I just need to cover up this, sub r equals to 0, correct? So a will be equals to half, correct? Right? Is it, sorry, b equals to half? Cover up the r, right? And I cover up a, right? How do I do cover up already? I also forgot. Okay, I forgot already, but okay, anyway, let's do the old traditional method. Okay, in the interest of time, I'll do the old traditional method. Okay, sorry. When r equals to 0, a equals to half, lor, correct? Lor? When r equals to -2, b equals to -half. So that means I need to cover up. I need to cover up. I need to ignore this and ignore this. Yeah. Yeah. When r equals to -2, I need to cover up this, right? Correct. Then is to look for b lah. Yeah, something like that. Okay, so this will be equals to 1 over 2r plus minus 1 over 2r plus 2. Okay, so you can think of it like that. Okay, then right, your summation from n to 2n. Okay, I'll just quickly present and I'll just touch and go because not in syllabus. So I'll just still teach anyway for the sake where in case it comes out or in uni you will need to use it suddenly, then at least you see before. They give you a slight advantage. Okay, so we will slot in n. So I have 1 over 2n minus 1 over 2 times n plus 2. Then plus the next term n plus 1. So 1 over 2 times n plus 1 minus 1 over 2 times n plus 3. Okay, then plus 1 over n plus 2 to n plus 2 minus 1 over 2 n plus 4 and so on, correct? Okay, so I think it will be nice if I can arrange this like that. Okay, so the method of difference, right, usually we'll arrange it like that. We can go all the way, right, until we have 1 over 2n minus 2. Okay, 2 times n minus 1. Sorry, 2 times 2n minus 1. Okay, minus 1 over 2 times 2n plus 1. Okay, then last one plus 1 over 4n minus, okay, sorry, I'm just minus 1 over 2 times 2n plus 2. Okay, something like that. Okay, so the thing is now if you start to observe, right? Okay, if you start to observe, okay, correct. There's a lot of cancellation. So this one will cancel with this, right? The next term over here, I will just shift down a bit. Okay, shift all this down a little bit more. Okay, I'll just add one more line. Okay, this one, this will cancel with this. So technically, this will cancel with somewhere over here lah. The cancellation will go on forever until we have something like that. Yeah, until we have something like that. So 2 terms in front, 2 terms behind. So this is the method of difference. Okay, once again, this is out of syllabus. So if you don't understand what I'm trying to do, it's okay. If it's in A level, they will give you the method. They will tell you what to do. Okay. Yeah, but in the previous year, they need to know how to do that. So, okay, so the final form would be equals to 1 over 2n plus 1 over 2 times n plus 1 minus 1 over 2 times 2n plus 1 minus 1 over 2 times 2n plus 2. Okay, so yeah, once again, this one is out of syllabus, so don't worry so much. I'm just showing you to, yeah, to expand your horizon. Yeah, expand your repertoire. Yeah. Okay, it's still 9 a.m. I think they're still La La Land. Correct, correct, correct. I just started only, but go crazy. Yeah. Questions? Yeah. I just put here for knowledge purposes. Okay. So don't worry too much. Won't come out one. I won't guarantee it won't come out, but at least less likely to come out. Okay. Can yeah, because very often at times, right? In one of the question in sequences of series, so they give you a university theorem, ask you to prove for the convergence of the fraction, that one, yeah. So they will bring things outside to tell you, but they will give you the theorem or give you the results to use. Yeah. So you just need to be adaptable. Okay. Okay, I move on. Okay, I quickly move on. Okay, let's go on to question 2. Okay, question 2. Okay, this question 2 is a reverse to question 1. Question 1 asks us to express the compact form, the compact sigma form into the individual sums. This question, we are going to do the reverse. We need to express the sum into a compact sigma form. So means we need a general term. We need to skills to find the general term. And these skills to find the general term actually come from EMATH. Okay, EMATH general term from your number patterns chapter. There's also the AP. There's also the GP. General terms. Okay, so let's take a look at the first one. We have A, 1 plus 4 plus 7 plus 10. So what is the general term? So if you were to use your AP, okay, if you were to think this is an arithmetic progression, common difference is 3, correct? So bless you. So the general term would be A plus n minus 1, common difference, correct? So this one would be 3n minus 2. Okay, then you test and see. So usually when we do the AP formula, okay, or when we use the general term thingy in EMATH, right, usually n starts with 1. Okay, or for this case, the r start with 1. Okay, so technically you want to use n or use r doesn't really matter, but for this question, n or r, it can lah, no problem, as long as you're consistent on what's the variable. Okay. That one I asked you. Oh, that one I will go through later. Yeah, I will bring the point across later. Okay, so this is 3n minus 2. Okay, so this one, right, the n will start with 1. Just test. When n equals to 1, the first term is 1. When n equals to 2, the second term is 4. So you test the n into this general term to make sure that it's consistent with this. Okay, so that's the first thing. And then you are summing to the first 30 terms, right? So if you're summing from 1, you count all the way, you have 30. So 1 to 30 will give you 30 terms. Okay, let's take a look at another form. Let's say instead of 3n minus 2, you decide to use 3n plus 1. Okay, 3n plus 1 is still possible, but n equals to what such that 3n plus 1 equals to 1? You must start with 0. Okay, you must start with 0. Can So over here, instead of 1, you have to start with 0. And the next thing that you need to do is you need to count out to 30 terms, correct? So n equals to 0 is 1 term, then n equals to 1, 2, 3, 4, 5. You count all the way up. So because you already include this as one of the terms, what will the last term, the 30th term be? N equals to 29. So the limit when you shift down, these two also need to shift down. The expression also need to change. Okay, so this is something like integration by substitution where you change variable, need to change limit, need to change expression, need to change the differential. Okay, same likewise when you do a change of this limits, you need to change the expression as well. Okay, technically speaking, if you itchy hand, if you itchy, right, you can 3n minus 5 lah. 3n minus 5 can, but you start from n equals to 2 to 31. Also can, but you need to check that when you sub in, right, it matches the terms over there. Okay, so when you change your limit, not just the limit change, but the expression also need to change. Correct. Yeah, correct. Okay, and then one more thing also, and one of the questions below, I think got 2 questions below, we'll see how does the expression change when we change the variable, okay, or when we change the limit. Okay, now the next thing that I also need to highlight is you need to know how to count the number of terms to verify. So over here, right, let's take this one for instance. How do I find the number of terms? Okay, I would need to take the upper limit minus the lower limit plus 1. Okay, so this one over here would be 31 minus 2 plus 1. So this will be 30 terms. Okay, something like that. Can so you use this to double check, and this will be true for anything lah. When you are counting, you'll be like that. Okay, can you arrange your class right from 1 to 25, right? So count the number of people from number 15 to 25. It's not 10, it's actually 11, right? Because 16 to number 16 to number 25 is 10 people. You need to add back the number 15. Okay, something like that. Can? All right, so this is part A. Part B. Okay, sum to the first two n terms. So this one, I think no issue. This one no issue because 3, 5, 7 over here, this is a very standard arithmetic progression, or E-maths, you already know this is 2r plus 1 or 2n plus 1, up to you. Okay, for this question, I will avoid n because we are summing to the first 2n terms. So we cannot have the variable to be a constant 2n. Okay, you have to differentiate and distinguish between what is a variable, what is a constant. So in this question over here, the r is your variable, your n is a constant. Okay, so when you're summing, right, you're actually rolling the variable, not the constant to n. Okay, yeah. Which question? Minus 2. Oh, can. I will use yours, but you upper limit must change. Okay, can. So like that, so 2r plus 1, then r factorial. So it's just simply r factorial if you want to start with 1. Okay, so that's the easy way lah. Okay, now then let's say if we are itchy also, okay, now you can get another expression. For example, if you want to start with 3, because you start 3, 5, 7, right? Okay, so also wrong, right? R plus 2. 2r minus 3. Okay, 2r minus 3 bracket r minus 2 factorial. Then this one would be r start with 3. Then this one 2n plus 2. All right, need to change. So you add by 2, by right also need to add by 2. Okay, if the lower limit add by 2, the top limit add by 2, but the expression is not plus 2. The expression is more often than not opposite. Okay, can So the easy way is to hook r equals to 1 now. Try to find the 1. Okay. Okay, last but not least, okay, we have sine 2, sine 3, sine 4, sine 5. So this is obviously r plus 1. Okay, then tangent, tangent square, tangent cube. So this one power r. Okay, so the first n term. So from 1 to n. Okay, problem. This one has alternating signs. Okay, this one over here has an alternating sign. So if you're not sure what to put, right, you start off with this first. I recommend you start off with negative 1 power r first. Then you test. Okay, when r equals to 1, this is negative. However, you see the expression over there, the negative is not there, right? It's positive, right? So you need to do some change. You can minus 1, you can plus 1. Okay, then you change it like that so that this matches the signs over here. Okay, can so one more time. If you're not too sure, you start with this first. Then you check the signs over here. Then if needed, then you add the plus 1 or minus 1. Okay? Okay, questions? Or question 2? Can question 2? Can? Okay, anyone still need to write anything? Okay, can okay. Question 3. So question 3, if a series is given by that, find the general term Tn, express the following sum in sigma notation. So same kind of exercise. But this one is the one that I need to go through a bit. This one, for those that I've collected, right, I feel that you have a very strong foundation. Yeah, I feel that you have a very strong foundation, and I'm very happy to see your scripts. Yeah. So for those that I collect lah. So okay, so let's see how this works. So how do we find Tn? Tn will be equals to Sn minus sum of n minus 1. Okay, sum until the previous term to find the current term. So we have 1 minus 2 power n plus 1 divided by n plus 2 factorial minus of 1 minus, okay, this one n minus 1, right? So this one with 2 power n. This one will be n plus 1 factorial like that. So we have can is can, but let's say if they want to simplify, and I will push one step further long. Okay, yes. So the question is, how do we simplify? There are many ways to simplify, by the way. So so far I've seen two different expressions. Okay. Now, so what we need to do is we need to observe what is n plus 1, n plus 2. So let's say you want to treat it as a single fraction, right? Or combine to a single fraction, we need common denominator, right? So the thing over here is correct. So let me give you an example, 5 factorial. What is 5 factorial? Okay, 5 times 4 times 3 times 2 times 1, correct? 120. Now, what is 6 factorial? Can I argue that this is actually 6 times 5 factorial? Can I say it's like that? Why cannot? Can what? This is 6. Sure. You want me to write the whole thing? Sure. But can, right? This itself is 5 factorial, correct? Right? Bully me only. Okay, okay. But yeah, can 5 factorial. So in a way, if I want to make the common denominator, there's two ways. Either I break this down to n plus 1 factorial, or I build this up to n plus 2 factorial. You get what I mean? Can? So what I need to do, okay, I will just give you an example. So I'll just do the n plus 2 version. Okay, combine into one common denominator. So I have a 2 to the power of n times n plus 2 to the power of n plus 1 minus 2 to the power of n plus 1. Okay, then at the bottom, I have n plus 2 factorial. So I will have n times 2 power n over n plus 2 factorial. Can. I think they never ask to simplify, so you can leave it like that. Yeah, so, but I think, let's say if they, in the event they want you to simplify, then this is the way to simplify. Okay, and you see the marks. If it's just 1 mark, then let it be. If it's 2 marks, then simplify. Okay. Okay, so this one be adaptable. Okay, part B, express the following sums in sigma notation. Okay, so this one, very obvious. Very obvious, very obvious. This one is very obvious, but I think some of you got a bit confused. So let's analyze term by term. 5, 10, and 15, right? This one obviously is 5R in a way. Okay? This is 5R. Okay, then the next one you see, right? 1 plus 2, 1 times 2 times 3, 3 times 4 and 5, right? That one, one way that you can think about it is R plus 1, R plus 2, or some of you R plus 1, R plus 2, R plus 3, because consecutive terms, correct? But what is the link between here, here, and here? Sorry, again, R times. So it depends on how you hook the sequence. So let's say if you're hooking the sequence from 1, 3, and 5, right? Then you need to do some adjustment. In a way like that. Okay. Now, the easier way is you need, for like 5, 10, and 15, right? You try to find your multiple of R in this whole expression. So where is the multiple of R? The multiple of R is actually over here, 2, 4, and 6. So this one over here will give you your 2R. Okay, so putting everything together, I sum from 1 to infinity. This is 5 times R divided by 2R minus 1 times 2R, 2R plus 1. Okay? Can so as much as possible, you try to find the multiple of R in this expression. Okay? Now last one for part B, part 2. Okay, B part 2. from r to 1 to the first n plus 1 terms. So this one over here, okay, I can have 1 over 3 minus 2r. Is it like that? No. A plus n minus 1b. So a plus n minus 1 times 2. So this would be 2n minus 1. Okay. Then this whole thing square. So this is at the back. In front, there is an alternating sign over here. So let's test out and see which one do we use. So negative 1 power r. Then when r equals to 1, this is negative. When r is equals to 2, this is positive. So yes, consistent, we can keep this. Eh, good question. When can you use n? When can you use r? So the problem is if your sum is sum to n plus 1, then already given n, right, you need to avoid the n. You need to avoid n. Correct. If on top is n, you have to change a variable. So you can use r. Another common one is actually I. Another common one is I equals to 1 and so on. Okay, if I not enough, use j. Okay, so this kind of summation thinking will help if you are looking to do computing. Correct, IJK lor. Yeah, sum across the row I, column J, and yeah, that kind of thing. Huh? Question 4, do need do question 4 I show you. Got. Is in math, not the sequence. Okay, so let's go on to question 4. Can Okay, so let me show you some GC thingy over here. Oh, it really brings Caesar out. No, I haven't. Okay, wait, sorry, let me load the GC for a while. Okay, so this one we press together. Let me show you how to do that. Yeah, it's now, but I watch later. You sure you want to stay back for math too? Oh, that's true. That's true. We'll end at 2:30, right? Okay. Yes. Yeah, okay. Two R plus one, but R need to start from 0. Right? Permute 3 meaning? What do you mean 2R plus 1 permute 3? Like 2R plus 1 P3. I'm not sure. I'm not too sure actually. Because of the 5. I'm not too sure because of 5. Wow. Correct. So the 2R minus 2 factorial and 2R plus 1 factorial can simplify. Yeah, the difference is R plus 3 factorial. Wait, again, sorry. 2R plus 1 square, right? This one. 2R plus 1 factorial. But where's the permute 3? Like, what's the form like? For this whole expression.
No, for the bottom part.
But why P3?
Because then it will give me 3 times.
No, it's not. It's not permute 3. Oh, I get what you mean. I get what you mean. Yeah, I think can. 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 Can.
Like, can I use it for like?
But permute 3 is permute 3 is n factorial over n minus. Let me find the formula first. Yeah. Yeah, I think. Okay. Yeah. Wait, let me test something first. What's the permutation formula? N factorial over n minus r factorial, right? Permute 3, n minus 3 factorial. So you keep n minus 1, n minus 2. Okay, I think can. I think it works. I think, yeah, I think it works. 10 times 5 on the outside. Because of the 5r. 5r. Yeah. 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 Okay. I'll start. Okay. Can okay, so let's go off to Ken. Let's continue. Question 4. Okay, Ken, all right. So the thing over here is we want to use the GC to do part A, part B, part C, right? Now, so there are a few ways to do this. Let's say if you are looking for sequence and table, right? Okay, if you're looking for sequence and table, we need to change to the mode. Where's my mode? Okay, need to change the mode to sequence. Okay, can or technically don't need change the mode also can just let it be also can, right? Then what you need to go to is you go to your expression over here. You just key in this thingy. So -1 to the power of variable, then variable plus 1, variable plus 2, right? Now you cannot graph this. Obviously, you cannot graph this. So what you can do is you can do the table one. Huh? Just key in the formula, then you just second graph, then you get a table, right? So you can get the exact values of this. So let's say if you want 20, right? 20 not so bad. You can scroll slowly to 20. Okay. But what if, right? What if the question asks for like find term, the 100th term, U100. So you do second table set. Okay. Over here you have your table start, right? So you start at 100 lor. Okay, then you go back to second table, then you see something. It's too small, yes, but this is how we do it if you want to skip the table. Okay. How can I change the fraction to decimal? For this one, a bit hard. Yeah, for this one, a bit hard. Correct. So this one, let's say if I start at 1, right? How do I change this fraction to decimal? Actually, I don't know how. To be honest, I don't know how. Correct. But I think for this question, right, we can keep it as fraction, I think doesn't matter. Yeah. I think it depends on what sort of answer you want. For me, I rather have fraction. So in the tutorial, right, or the video, right, they have all the decimal, but I want fraction instead. That's even weird. Mm? Uh-huh. Okay, let me try something first. Can yeah, can. I do this lor. Can you see what I do? This one, the fraction to decimal thingy. Yeah, like that lor. If it's, yeah, no choice. Okay, no choice. Okay, can so something like that. Okay, now let's say, right, if they want to ask what is the limit of the sequence, or what is the converging limit of the sequence, right? How do we do that? We can test with 100 lor. You can test with 100, you can test with maybe 200, then you can see what's the number at the end. Or let's say if you want to jump, right, then you can do second table set, you change this value over here. Okay, the step of the table. Every step maybe 50 step, 100 step, but the calculation will be long lah. It will take some time to compute, but they will give you the limit. But technically speaking, you don't need to go there. You just need to change table 1 to make it easier to calculate. Then just go to a far point, maybe 400. Then you can see the limit already. Yeah, I can see limit already. This is almost 0. Okay, so this sequence converges to 0. Okay, something like that. Can all right, so this is for the first one. Now then, right, for part B, find the sum of the first 10 terms of the sequence. This one no choice, we have to go out to the main page. No choice, but we have to go out to the main page, but we can use alpha F2. Okay, alpha F2, can you see got summation over here? Right, just sum lor, just use the summation. So this one variable from 1 to 20, 20 terms, right? Sorry, 10 terms. Yeah, 10 terms. Then over here, fraction, negative variable, sorry, negative 1. Power variable over, yeah. Okay, something like that. Then enter, then you got answer already lor, like that. Next one, part C, find U5 plus U6 plus U7. You're starting from n equals to 5, right? So you go up, you copy, enter, you copy, then you go all the way back, change lor, from 5 to 10 lor. Sorry, 5 to 20 lor. Then enter, then got answer already like that. Okay? Can so it's not so difficult lah. Okay, as in like you just need to know that this exists inside so that you can use your calculator to evaluate. Okay, can no, cannot lah, only half the lesson. Yeah. No. I give you 3-minute break, Kendrick Lamar break, so can, yeah. Yeah. Okay, can all right. So this is for question 4. Question 4. All the way. I'll go through all the way. No choice, no time. I want to finish. Yeah. Can? All right, so something like that. Let's look at question 5. Question 5 now, right? We are looking for this one called the convergence of a sequence. Okay, so this topic over here, okay, convergence of a sequence. Okay, all right, so the thing is that why are we studying the convergence of a sequence, right? Is that we want to find a limit to a certain function. Okay, like where does it go to at the very, very far point? Like what number does it go to? If it blows up, right, that means that there may be some unboundedness thingy that you need to consider. You need to change functions such that you'll contain that variable or contain that term, something like that. Okay, so when you're in engineering, right, you need to look at some of these to track the limit. Not like this lah. Okay, yeah, not like this, but something more complicated in engineering. Now, the other kind of thing that you do for convergence, right, not just convergence of sequence, you do a convergence of a series where you add certain things, okay, and then you see that the series converge, okay, and the one level up is the convergence of the function, okay. So the convergence of a function, right, like one example would be your Maclaurin series. The more terms you add, the better it fits the curve, right? Something like that. The more curves you have, and then, sorry, the more turning points you have, the more terms you need to add. Something like that. Okay, so that will be the convergence of a function. Can So let's look at A. Okay, so without using GC, this one we will use the algebra technique. So how do we do this? I will present to you 2 different notation. You choose what you want to do. Okay, now the easier notation is as r goes to infinity, what happens? 1 over this becomes divide by r. Don't need to divide by r. This one, very obvious. This one will go to 0, correct? Because the denominator will become very big, right? So as this one goes to 0, so your UR will approach 0 as R goes to infinity, just like that. Okay? Can Now, the alternative working, okay, the alternative working would be, now the limit of this function, the limit of this function as R goes to infinity, straight away equal to 0. Okay? Can Right. Next one, part B. Part B. Now, we need to do some analysis over here. So this is the one when we have infinity over infinity or 0 over 0. Okay, this is where we need to consider some algebra techniques to help us to make life easier. Not long division, but divide by r, divide by the highest power in the polynomial, so that I can reveal my 2 over r and I can reveal my 1 over r like that. Okay, and because of this, as r approaches infinity, so UR will approach 5 minus 0 over 3 plus 0. So this one will approach 5 over 3. Okay, something like that. So in the same way, limit of, okay, when r goes to infinity of this fraction over here, yeah, will be the same. The limit, you haven't do the limit function yet. Okay, something like that. So this will be equals to 5 minus 0, 3 plus 0. Correct. The limit is the proper notation that you will see in uni lah. Okay, but actually both notation works. Both also equivalent. Yeah. Okay. Okay, it's just the limit of a function lah. Okay, or limit of a sequence. Something like that. Okay. So this will be part B. Okay, part C, same thing. Okay, part C, same So okay, so what I will do is I will massage or try to find out how do I get the equation ready first. So this one over here, if you sub in infinity, right, it's going to be infinity over infinity, right? So then we need to make some changes again. So make some changes by dividing by the highest power in the whole highest power in the whole fraction. Okay, so you will have 1 minus 2 over r over 3 plus 4 over r squared. So as r approaches infinity, your UR will approach 1 minus 0, 3 plus 0. So this would be roughly 1 over 3. Okay, so in the same way, you can do the same for the next one. Okay, so this one I won't say much, but yeah. Okay, same kind of working, just different notation. Okay, can so this is how we write lah. Okay, so this for question 5. Okay, now finally we are done with the basic parts of summation or basic parts of sequences and series. Now we enter the real deal. Okay, can so now we are entering the real deal of what's going on. Okay, so this one your brain cells need to be activated over here. If your brain cells haven't been working out, yeah, you need to open now. Okay, but if you've been working out in the previous questions already, this one you stay alive. Can okay, this one I try to stay alive. Typically, this question I need to write the whole, like almost the whole board one. So, okay, but no, because recording so can okay. So, all right. So let's move on to question 6. Sorry, do you still need? Still need. Okay, okay, okay. Don't worry, I'll put on one note. I'll put on one note. Yeah, but you remind me to. Yeah, I'll try to put on one note. Okay. Okay, let's go on to question 6. Okay, question 6, we need to find the following sum. Okay, so this question, right, we need to be very careful. Over here, right, we will need to be mindful that but number one, what is variable, what is constant. Okay, so for this one, which is the variable, R or N? R, no. R is the variable. Okay, then this one is the constant. Okay, same, R is the variable, N is the constant. So the one that roll is R. Okay. Now the next thing that we need to take note is that for these kind of things, right, there are generally two approaches that we can use. Okay. So number one is that if you've watched the lecture, right, what's the standard method that they use for here? This is an arithmetic progression. Can you see how is it an arithmetic progression? Okay. So if you're not too sure, correct, correct. So for method one, right, the 2n is not affected, correct? The one that's rolling is the 2r. So this one, right, is to recognize pattern. Okay. And for this case, right, it's an AP lah. So let's set up and see. So we start with 0, right? So when r equals to, this one to do right, when r equals to 0, the first term is 2n plus 1. When r equals to 1, the second term or u1 would be 2n plus minus 1. When r equals to 2, the next one is 2n minus 3. Correct? So I think very clearly, right, you can already see this one has a common difference of negative 2. This is an arithmetic progression with common difference negative 2. Okay, now also before we set up, we need to find out one thing. What is the number of terms? Okay, what's the number of terms? The top minus the bottom plus 1. So this one we have n terms. Okay, right. So I think now we are ready to form our summation already. So r equals to 0 to n minus 1, 2n plus 1 minus 2r. Okay, so this one over here would be, okay, we are making use of the formula, okay, sum of AP. So this one Sn, okay, n over 2 a plus l. You want to use the other one also can, up to you. Okay, but a plus l will work nice lah. Okay, so let's try. So this one would be n. So the n terms, okay, divide by 2. What's the first term? The first term over here, 2n plus 1, right? Okay, then plus the last term. What's the last term? So this would be 2n plus 1 minus 2 times n minus 1. Okay, if you are not too sure, is to sub this into the r. Okay, can see how this works? Last term. So this one sub in over here. Last term, correct? Right? Can, all right. So you can simplify this to n over 2. You have your 2n plus 1 plus 2n plus 1 minus 2n plus 2. So altogether, this would be n over 2, 2n plus 4. Then this would be n plus 2. N squared plus 2n also can. Okay, so this is method 1. Can, all right, so this is method 1. Okay, I'm going to teach you the other method, but I let you compare and see. And then we'll make the what? Make the do. Okay, I'll make the comparison. Okay, so method 2. Okay, second method, right? What we're going to do here is we need to expand the summation, which is something that I've covered in the summary lecture. Which one? Method 2? Not for this question. Not for this question. Huh? In a way, okay, correct. Yeah, you're correct. Okay, so what we need to do over here is we will expand the summation, right? So here we have r equals to 0 to n minus 1. Okay, so question, put in the question first. Okay, so there are many ways to expand this out. Okay, now what I would like to expand out with is that I would like to expand out my constants and variable. Okay, so if you would like, you can expand out like this. You can expand out summation of 2 summation n plus summation of 1 minus 2 summation of r. Correct? You can expand like that. Okay, because we are just multiplying, distributing. Because we're summing anyway, right? So we can distribute the summation. Okay, can now you can expand like that. Okay, and then this one you add one by one, you can do that. Okay, or maybe this is easier, so maybe I'll just do this. Okay, okay. Yeah, the r is the one that's changing. So r from 0 to n minus 1 of, okay, 2 times this plus r from 0 to n minus 1 of 1 minus 2 times of this. Okay, something like that. Can Okay, so this one over here, right? We are adding constant n, correct? This n over here is a constant, right? Right? This n over here is a constant. So how many terms are we adding? How many terms are we adding? This one, right? We're adding n terms, right? Correct? So means this would be 2 times n times this n. Okay, n times of n. Okay, in the same way, I'm adding n times of 1. I'm adding 1 n times. Okay, the first one is I'm adding 2n n times. The second one is I'm adding 1 n times. So that's why it's a multiple. Okay, can accept? Can accept? Okay, all right, now next one, the last term over here. Okay, the last one over here, right? Okay, this one up to you. Okay, if you are familiar, this one, if you know that this is an AP, correct? Common difference is 1. First term is 0. Last term is n minus 1, correct? So if you can do this, this would be minus 2 times. Okay, so this would be n over 2 A plus L, like that. Okay, can n over 2A plus L. Or the other way to do it is you change variable. Okay, the other way to do it is to change variable. So you can change this, right? So when r equals to 1 to n, okay, r from 1 to n. So when r, okay, so what do you need to substitute to get r equals to 1, right? So you need to replace r with r minus 1. So you get r minus 1 equals to 1, so 0. So r equals to 1. R minus 1 equals to n, r equals to, sorry, r minus 1 equals to n minus 1, r equals to n. Then your expression over here is to sum r plus 1s, r minus 1, something like that. Yeah, you can do that change lah. Okay, but technically you're making it more complicated, so we don't do that. Okay, all right. The reason why I mentioned change of variable, right, is because there's also another property where if you sum from 1 to n of, sorry, 1 sum like that, right, there's an identity half n plus 1. Okay, now let's say if you're summing r square, this would be 1 over 6 n 2n plus 1, if I'm not wrong. Sorry, n over 6 n plus 1 2n plus 1. Okay, then if it's r cubed, this would be 1 over 4 n square n plus 1 square. Okay, something like that. Okay, once again, I've mentioned also, if you want to use, right, this one is technically from here, Sn. Okay, the first one is technically from Sn. The second one and the third one, right, if they want you to use, they'll be given to you. So don't worry too much. But you just need to know that there's a fact that you may need to use this. Okay, this one is we're adding 1, 2, 3, 4, 5 until n. The second one is 1 square plus 2 square plus 3 square all the way until n square. The third one is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, all the way to n cube. Okay, and they have their own identities, they have their own formula. Okay, last time there was this topic called mathematical induction where you also need this lah. Okay, something like that. And you just need to know this. This one you just let them give. Okay, this one should know. And this one actually can derive from here because it's like this lah, right? It's like that. Okay, so it's technically an AP, so you don't have to worry too much also. Okay, so you just need to bear in mind that you can expand your summation, you need to identify your AP. So after long story, right, we have this 2n square plus n minus n square minus plus n. So over here I have n square plus 2n. Done. Or if you want n plus n plus 2, also can. Okay? Can So this one is the long story which and one last note is if you want to use these identities, bear in mind the R must start with 1, this one must end with n. Okay, if you want to use these identities, the first one must be R equals to 1, the last one must be R equals to n, 1 to n. Okay? And because of this, right, we will need to see how does this work on the second one. Okay, can we'll see how does it work on the second one. This one still need method 1, method 2. Okay, so to round this off very quickly, for this question, right, which one is the easier one, A or B? Method 1 or method 2? Obviously, method 1 is the easier one. Okay, so if there's a shorter way, please use a shorter way. You need to know both, but if you know a shorter way, please use a shorter way. Okay, now if you are comfortable with expanding the summation, you don't have to care about all these things. You just need to know that these are constants. You just n times whatever constant this is. This one is just the rolling number, right? So you just use Sn or the first one. Okay, the first formula. Can So yeah, so it's just like that, like that, like that. Then simplify also can. Can you don't have to change variable and so on. If it's the change of variable, that one we need for the next one. Not say next one, question 7. Okay? Can something like that. Okay, so let's continue on with part B. Okay, part B. Okay, so now we need to sum R from n plus 1 to 2n of this. Okay? Now, yeah. And then they also give this. Okay, this one is given. Okay, so the thing, how do we do this? No choice. When you try to work out the pattern, right? The pattern is not a linear pattern, correct? So what do we need to do? No choice, we have to expand and work it out one by one. Okay, so this one will be sum of R square plus sum of, okay, I will rewrite this as 1 over 3 power R. Okay, to visualize my terms. Can I? All right, so now let's take a look at this. Okay, let's take a look at this. Okay, so the first one that I'm going to do is now this one, right, is a sum from n plus 1 to 2n. Okay, this is a sum from n plus 1 to 2n, right? So technically speaking, I will change this to, okay. So means that if I want to express and make use of R equals to 1, because this one, the identity given over here, right? R must start with 1, correct? So if I want to make use of this R equals to 1, right? I need to change this side to 1 also. And I can borrow it by this. So sum of 2n minus sum of n plus 1 minus 1. Okay, example again. Okay, sum from the 5th term to the 10th term, right? Correct? So this will be S10 minus S4 because you want to include the 5th term. So you have to take 5 minus 1, correct? So in the same way, your n plus 1 over here need to minus 1. Can I? All right. So means this one, right, I can break it down to, okay, so now r from 1 to 2n of this r square minus of sum, okay, r from 1 to n. Can? Of r square. Can? All right. The next one, I'm getting ready for the next one. Okay. The next one over here, right, if you see, this is actually sum of 1 over 3 power r. So 1 over 3 to the power of n plus 1. 1 over 3 to the power of n plus 2. 1 over 3 to the power of n plus 3, and so on until 1 to the 3 to the power of 2n, correct? So what kind of thing is this? What pattern is this? This is a geometric progression. Okay, what is the common ratio? 1/3. Okay, how many terms? How many terms? Top minus bottom plus 1, right? So this is n terms. Okay, can n terms. So I think we are ready for the formula already. Can? Okay, so next step. Okay, so this and this, we can make use of the identity given to us. So we will have something like we replace n with this number on top. Okay, so we have our 2n over 6, then 2n plus 1, then over here I have 4n plus 1 minus, okay, this one will be standard. Mm. Okay, something like that. Now, then the next one, this is sum of GP, right? So this one, the Sn will be equals to, what's the formula? A 1 minus r power n divided by 1 minus r, correct? This is the formula for Sn for a geometric progression. So we make use of this. So we have something like, what's the first term? First term is 1 over 3 power n plus 1. Then over here, 1 minus, okay, common ratio 1 over 3 power n divided by 1 minus 1 over 3. Yes, this is very long. Damn long. Okay, so this one over here, okay. So the first two term, right, how do I simplify, right? I can massage, correct. I can massage everything to a nice single compact form. So I can take this out. I can do a n over 2, n over 2 somewhere. Oh, yeah, 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 yeah. Yeah, 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 谢谢. Okay, n over 6. Okay, so I can pull out n over 6. I can pull out 2n plus 1. Then over here, I have 8n plus 2 minus 2n, sorry, minus n minus 1. Okay, can Then the one on the right need to work for it. So this is 1 over, okay, so this one will be 1 over 3, 1 over 3n, split the top. This one will be 1 over 3 power n. Okay, then divided by 2 over 3. Then this one over here, okay, can cancel and cancel. Okay, something like that. Okay, last but not least, okay, finally we're at the end. 2n plus 1, 7n plus 1, plus 1 over 2 times 3 power n of this ungodly thing. Yeah. All right. This, yeah, this looks very ungodly lah. So unsightly. Can ah? You okay, bro? Huh?
They're not like us. They're not like us. It's like, so that's the one is supposed to like be only person.
Squid game, squid game. Can? Okay, questions. Question. So once again, right? Concept wise is APGP, pattern recognition. Okay, able to understand what does this notation mean. Okay, is algebra intensive. Okay, but nothing that you cannot do. You just need to do this slowly and to work out the details. Okay, there's really a lot of concept packed into this one question over here. So this one you just need to be, yeah, be good lah. Okay. Yeah, but you'll be there lah. You'll be there. Can? Can So you can imagine, right? One concept, two concept, three concept, four, five concepts, then the rest algebra. Wow. So it's, yeah. Yeah. Oh, is my hair fake?
Suck at this.
Okay, let's move on. Okay, let's push to the very last question as fast as possible. Can All right. Let's complete question 7. But 8 warm up for next one lah. Yeah. Okay, can 7. Yes. Okay, I'll take your advice. Let's jump to 8. Let's jump to 8. It's okay. Let's jump to 8. Can? Okay. Let's jump to 8. Then remind me on Wednesday that we are doing 7. Okay? Can. Because 7 really takes some time. And I think that's something that I think I want you to take time. Okay, 8. Now, question 8, right? This kind of thing, this concept is called recurrence relation. Okay, so what is the recurrence relation? This is actually a expression, right, that depends on the previous term. Okay, so this is called recurrence relation. So this one over here, technically we call this a first order recurrence relation because it uses the direct previous term. If you need 2 terms before, it's called a second order recurrence relation. Okay, but regardless, you just be flexible. Okay, now what are we going to do here, right, is that usually for H2 math, okay, the recurrence relation that we'll be doing, right, are the easy recurrence relation. Further math, we learn how to solve and get the general term, the general solution. But for H2 math, we just need to evaluate. Yeah. Yeah. So okay. So let's try and see what does this mean. So over here, right, they already give the first initial condition u0 equals to 2, and they are looking for un, right? So let's look for the first term. So u1 will be equals to un minus 1, which is the previous term, plus n cubed plus n. Okay, what is the previous term? The previous term is 2 plus 1 plus 1. So this one will be equals to 4. Very direct. Okay, so this one must know how to do because will be very common in A level. Okay, this recurrence relation, right, is quite common in A level these days. Can? Okay, let's take a look at U2. We are looking for the second one, U2 second term. So U2 will be the first term U1 plus 2 cubed plus 2. So this one will be, the first one is 4, 8, 2. So 14. Okay, U3, last one. This one depends on the second term. 3 cubed plus 3. So this would be 14 plus 27 plus 3, 44. Okay, something like that. This is within the syllabus. This is a past year A-level question. Okay, can all right, so I think it is a good place for us to stop here. Okay, you just need to know that this one, right, is not really covered in the lecture, right? But you need to know that this thing exists and it's pretty common in A levels, and it's not difficult. It's really not difficult. Even the questions that come up at the end of the tutorial, right, it's not difficult. Don't worry. Okay, can do one. So just have the grit and perseverance. Okay, all right. So I guess that's all today. Can then on Wednesday we'll continue on with the other questions, the remaining questions. Then we try to finish as much as possible. Can all right. That's all.
Why do you say that?